Ready to go. So yesterday we talked about what radians are, and we talked about converting them. And I told you, I gave you that little analogy of learning another language. Learning radians is like learning another language. And so at first you're going to be converting constantly and thinking about the degrees, but your goal is to eventually be thinking in radians. And if you can get there, then you're going to be golden, okay? Because today we're going to start using them. Remember we did the grade 11 review? Now we're doing all of that all over again, but much more slowly. Not all of it in one day, but we're going to do it all over again. And but now with radians. So I said this before, every answer you give from here on in has to be in radians. And what you can't do is convert to degrees, solve the problem, and then reconvert back to radians. No, can't do that. If in your head, even for the unit test and the final exam, if in your head you're always converting to degrees to think about it, that's fine. I'm actually going to even, when we start graphing, I'll recommend that as a possible strategy, okay? Because radians can take some time to get and they can be tricky. But all your work has to be shown in radians, and all your answers have to be in radians, or it's like 0, official marks for that. Okay, so let's take a look at these special triangles again. Which special triangle is this? What are the side lengths?
1, 2, and square root 3.
Very nice. 1, and I think in this order, square root of 3 or root 3. Very nice. What is a right angle in radians? How'd you get that?
Because another right angle is 90 degrees, so 90 times 2 is 1.
Okay, nice. So linking it back to that, like that's kind of maybe your anchor point. Everybody's different, right? There's no right or wrong answer to that. How did you get that? Everybody's different. But I'm curious to wonder, to find out how people are thinking about it. But an anchor point of pi is 180. That's a really good way to start. It's a good strategy. Okay, what is this angle in degrees? 60. And what's that in radians? And how'd you get that? Nice. Okay, and then the last one, a 30-degree angle, what's it in radians?
Pi over 6.
Okay, pi over 6. Like, when you look at it right now, it's very foreign. It'll be really interesting at the end of this unit to reflect back and be like, oh yeah, no, now I just think about it in radians. I just label it in radians. Pi by 3, pi by 6, and then the right angle we don't always label, but you just kind of know it. It's really interesting how it only happens in a week or two. This is an aside, so I don't think you want to copy this down necessarily, but just watch this, because this is, again, maybe your goal for the end is to be able to do something like this. This is pi by 6. If I wanted this to be over 6, what would I make it? Well, 3, because 3 over 6 is the same as a half. 1 over 2 is a half, right? What about this one? So if I multiply by 2, this one's going to be 2 pi, because 2 over 6 is a third, and 1/3 pi over 3 is a third, right? So, and then take a look at this. It's kind of interesting. It's kind of a neat way to think about it. 1 plus 2 plus 3 is 6, which is a whole. And that makes sense. Those should add up to pi, because that's 180 degrees, and all the 3 angles in a triangle add up to 180 degrees, right? But it still fits. But you might not be able to do that kind of fraction math in your head that quickly, even though, in grade 9, we try to drill it into equivalent fractions and that kind of stuff, but we just don't practice it enough, unfortunately, even in high school. But now we're going to. So you will eventually start, I think, a lot of you at least, be able to think in fractions. Okay, the second triangle, this is my 90-degree angle. And what are the other two in degrees? And what's that in radians? You know? Yeah?
Pi over 4.
Pi over 4, how'd you get that?
It's just 180 divided by 4.
Nice. Or 90 divided by 2. It's a funny thing that, this is such an easy concept. what's a half, of a 1/6? What's a half of that? 1/12. Some people might say a third, right? Because 6 divided by 2 is 3. But you actually multiply the bottom by 2, because that's like dividing the whole thing by 2 as you add a 2 to the bottom. So it's 1/12 is a half of 6, right? And again, that if that seems complicated, it's not complicated. You just haven't done it enough times. But once you start doing it, it becomes so familiar and it becomes second nature. And the side lengths of this guy are 1, 1, and √2. So there's our new special triangles. Whenever you draw them, you're going to want to draw them and start putting the radians in. At first, when you're doing your homework, maybe do it every single time. Maybe draw, for every question, draw the triangle you need and label it. And then you'll kind of, after doing it 5 or 6 times, you'll have it. Does that make sense? Any questions about any of that? All right, let's get started. Our first one's not even an easy one. Not as easy as they can be, at least. Determine the exact value of each of the following. All right, how would you even start a question like this? This is what I'm going to do. I'm going to draw it. How many times have I said that? That sketching, drawing is so, so valuable in this course more than any other. And if you want, I would say put your pencil down and just watch. This is my thinking. Everybody's different. I've seen people do it different ways. You got to work through it. We're only doing a few examples of each type of question today. But we're going to practice this more on Monday anyway. So you're going to have a couple of days to really nail it, okay? But this is how I would do it. So 4 pi by 3 is more than 3 pi by 3. 3 pi by 3 is like 1 pi. That's 180. Everybody's good with that? So I've gone 3 pi to get there. Sorry, 3 pi by 3s to get there. 60, 120, 180. 3 pi by 3s to get there. How much do I have left to go? One more pi by 3. I've got 3 pi by 3s I've done. I need one more pi by 3 to have 4 pi by 3s. We're counting pi by 3s. 1, 2, counting thirds. 1/3, 2/3, 3/3. That's a whole pi, 180 degrees. One more pi by 3. Here, I'm going to draw it a bit better to scale. 60 degrees, so it's kind of down a little bit. So there we go. Right? It's all about finding the related angle. So this is pi by 3. You don't have to write that line down, what the related angle is in this case. Sometimes you do. In this case, you don't. But you could. Doing these kinds of questions, you could always be like, I'm going to find the related angle and write it down. That's my first step. That's my strategy for a question like this. That would be a great way to do it. Okay. Cast tells me that cosine will be negative in that quadrant. So cosine of 4 pi by 3 is equal to the negative of cos of pi by 3. Let's go up here. Cos of pi by 3, cosine is adjacent over hypotenuse. So that's adjacent is 1, right? Here's pi by 3. So 1/2. So this should be -1/2. Are we okay with that? If your calculator's in the right mode, cosine of 4 pi divided by 3. You see that? Negative a half. Okay, so it worked, in this case at least. Any questions? But you cannot just use your calculator because this step here is absolutely necessary, right? On a test. First of all, you won't have a calculator for a question like this, but second, for like sometimes you won't. Second of all, you have to show that step to show me that you've done the work and the thinking. Any questions? How are people feeling? Like go way over your head, kind of follow it, kind of not follow it. Like think about where you're at with all of this. Let's try another one. Don't forget, you won't be perfect at this at the end of this lesson. Like even if you only understand it, well, that's why you go practice and try to work it out. And why I put resources online so you can go back and revisit them if you need to. You go back and just watch that one example in the video that gets posted and just watch it a few times over and over again or something until it clicks. Okay, so let's try this one again together. 3 pi by 4. How did we think about it in the last example? I thought about a whole pi. This is less than that, right? So like what quadrant am I going to be in? What's my related angle? That's what we're working at. Quadrant 2. So if I went all the way around, that would be 4 pi by 4. So I'm going to go back one. So I just get 3 pi by 4. And what's left is my related angle, which is pi by 4. I didn't say this, but I'm sure you know that, but we're doing tangent here, cotangent, so we're thinking about tangent, right? So cast tells me that it's negative in this quadrant, and cotangent is a reciprocal of tangent, so I'm going to go over here a little bit. So this is going to be negative 1 over the tan of pi by 4. Folks, stop and ask questions if you need them. What's the tan of pi by 4? So we go to this triangle. If this is my angle, tan is opposite over adjacent. I mean, I know a lot of you have already done this. You've already got the answer in your head. It's 1 over 1, which is 1. So it's negative 1 over 1. So my answer is just going to be negative 1. And you can go ahead and try that on your calculator as well. Now, most calculators, I'm sure there are some out there, but I don't think I've ever seen a student with one that have a button for the reciprocal trig ratios, right? You can do sine and inverse sine, but you can't do cosecant directly on your calculator. So you would do it as like 1 divided by tan of 3 pi by 4. Like that's how you would do it on your calculator if you wanted to check these. And it's a good idea to check them if you have your calculator there. I think absolutely, why not? Now you'll be able to check your answers at the bottom of the page or solutions online or whatever as well. But okay, cosecant 11 pi by 6. Let's get through this one. Anybody want to get us started? What would you do to start? John? What would 2 full pi? What would 2 pi be? Yeah, but what in terms of like the fraction over 6? Very nice, right? 12 pi by 6 is 2 pi. See how we're already starting to think in fractions? 12 pi by 6 would be 2 pi. So 11 is just below that. So I can do this. And this is going to be pi by 6. Another thing that I think is like you really have to train your brain to get used to, and you may never, so you may just have to keep kind of, I don't know, reminding yourself or something, is that pi by 6 is smaller than pi by 3. Like 60 has a 6 in it, but then pi by 6 is 30 degrees. It's the opposite. And sometimes your brain plays tricks on you, and so you get the wrong one in there, and you think this is the 60-degree angle, the bigger one. I don't know how you avoid that. Like it's tough, but again, with practice. And so cosecant is sine, reciprocal of sine. So this is, and sine is negative in that quadrant. So again, this is negative 1 over the sine of pi by 6. All right? Go up here. Pi by 6. Sine is opposite over hypotenuse. That's 1 over 2 again. So this is negative 1 over a half, which I hope you know works out to 2. And so it's negative 2. I had this conversation with somebody yesterday. I don't think everybody was involved. It was kind of at the end of class. On the no calculated part of the test, we're not really trying to test your fraction skills. Like that's not really the point of it. The point of it is testing your understanding of the trig. That being said, the byproduct is you got to be able to do the fraction part in your head as well, which is fair 100% in a grade 12 university level course. Oh my goodness. But you can do some minor, simple fraction math in your head. Especially it's the same denominators all the time, right? We don't start doing like 19 over 57 or something like that. So just be ready for that. Okay, questions? We'll move on. This question is no different from the last few that we've done. Not really any different. It's just longer because we have to do more of it all together. And so it's just two things multiplied by each other. Sometimes the answer ends up requiring a little bit of work to reduce it as well. Remember yesterday or the day before we talked about rationalizing the denominator? None of those we had to, but if they worked out that way, you would. Okay? So I'm going to go through this one a little bit more quickly, just because we don't want to take a ton of time on the same stuff. If you can't follow all the little details, that's okay. We already did those other ones more slowly. Practice, and then you'll get better at these two. Sine of 3 pi by 4. 3 pi by 4, we already saw that one. It's in the second quadrant. Right? It's between a half and a full. It's 3/4. So it's the second quadrant. Second quadrant, sine is positive. So this equals the sine of pi by 4. Secant is cosine, so this is 1 over cosine. 4 pi by 3 is in which quadrant? We already did this one too. Third quadrant 3, thank you. So we've gone past 3 pi over 3 to 4 pi over 3, but we haven't gone all the way into the fourth quadrant yet. Right? We've just gone 160 degrees, 4 pi by 3 into the third quadrant. So my related angle is pi by 3, and cosine's negative in that quadrant. So it's sine of pi by 4 times negative 1 over cos of pi by 3. All of this is exact value stuff, so you're not using your calculator to evaluate these. We're using special triangles. Remember what I said. The learning goal on Monday, I would recommend not using your calculator to challenge yourself. That's your goal, to be able to do this without your calculator. So why use your calculator when you're not going to be able to in the end anyway, right? So sine of pi by 4 is opposite over hypotenuse. So 1 over root 2. Cos of pi by 3 is opposite over hypotenuse. So 1 over 2. So negative 1/2. I said opposite, but I looked at adjacent. You're right. Adjacent, sorry, I said opposite. But I think 1/2 is right. Well, it is right, yeah. Okay. So now we'll multiply here. So it's going to be negative 1 over 2 root 2. And I'm going to rationalize the denominator. Again, if this is something, I'm not going to reteach this right now, but if it's something you're not sure how to do, you're not sure how this works, ask about it, and I can go over it more slowly, MSIP or at lunch or something like that.
No, the negative 1/2, isn't it? Negative 1 over negative 1/2.
Oh my gosh, you're right. Thank you. That, yeah, very good. 1 over 1/2, which is 2. So I'm going to move this 2 here. That's good, right? Now we're good? 2 should be on top. Yeah. And when I rationalize this, I get negative 2 root 2 over 2. And the 2's cancel, so I get negative root 2. A little bit of extra work in a question like that. And I know that went fast and you haven't seen it that many times, so you might need some time to work with it. You might need to ask more questions. Yes?
Is there still the 2 in the denominator now because you changed the half into a 2?
What do you mean, here?
Like,
There?
yeah.
No, because I divided these.
Oh, okay.
That's where they went. That's why it's gone. And again, you can check that on your calculator. Oh, so if you printed out the lessons, I wasn't sure what we were going to do, so I had them as 2 lessons, but we're going to do it all today, and then Monday's going to be more like a work period. Okay, so we're going to do a couple of different kinds of questions today instead of splitting them up into 2 different days. So if you printed all the lessons, just the next one. But it's all, or you could just write it down because it's also, like you just write it on the back of the page. It's just, this is all it is. Does that make sense? All right, this is the other kind of question where you're given like the answer, you have to find the angle. Sine theta is negative 1 over root 2. We've already done these in the grade 11 way in degrees, so now we're looking at them in radians. And remember, your answer has to be in radians. If this were grade 11, how would you start? What would you do? What would you be thinking? Not sure? Well, I'll give you a hint. 1 over root 2, what does that tell us? Yeah, which triangle we're in. So like, remember when I said you could always be drawing it? So let's draw it. There's my 1, there's my root 2. So this is pi by 4, because it's that triangle, right? And that's my related angle. Sine is opposite over hypotenuse. 1 over root 2. So when you do that, you have to make this statement. You have to state the related angle. Theta related equals pi over 4. Like I want to see that. Okay? And then the next part of this is cast. So it's negative. Where is sine negative? In the bottom 2 quadrants. Remember that little demo that I showed you on Wednesday about how the related angles, we talked a lot about this. There's a related angle in each quadrant, right? If you go up from the x-axis or down from the x-axis, you get that same, you get a triangle, similar triangles everywhere. So we know it's pi by 4, but we don't know, like there's 4 options. And 2 of them are negative, so we're being a detective. We figured out the angle, we figured out the quadrants, because we've got the negative sign and we've got the cast rule and we use special triangles and we know sine, SOHCAHTOA, like we used all these different ideas. So why trig, this angles in standard position with trig is so different from a lot of other stuff. There's no algorithm. It's not step 1, step 2, step 3, step 4, step 5. Like completing the square. Remember doing that? It's like an algorithm. You just do this, do this, do this, do this, you get your answer. Trig's not like that. You got to pull little bits and pieces of information from all over the place. And that's why a lot of people struggle with it. Because it's not clear, and they don't know. Yeah, and there's all these different kinds of questions. It's very confusing. So we're gonna say theta in quadrant 3, and remember this is theta related. You do not have to show all these steps, but plus pi or pi plus theta related. You don't have to show that, but as a reminder, since it's early, we haven't done a lot of it. So that's pi plus pi by 4. What's that?
Wouldn't that just be 2 pi over 4?
Why would it be 2 pi over 4?
Because we're just adding 1 to the pi's.
Okay, interesting. What do you think?
5 pi over
Why do you think it's 5 pi over 4?
Oh,
because it's like a full, because it technically would be like 4 pi over 4, so 4 plus 4 is 5.
Yeah. So in grade 9, when we talk about like adding fractions to whole numbers and stuff, and you get a common denominator, and you do all this work, so like 1 is like 4 over 4, and you would show that. So 4 over 4 plus 1 over 4, you add the tops. But when you start thinking in fractions, start like making sense of them, you're just like, well, that's like 4 plus 1 more, so it's 5, right? So it's 5 pi over 4. But if you want to see it, it's like 4 pi over 4 plus 1 pi over 4. So 4 plus 1 is 5, right? So that's the long way that you would do it, but you can start thinking in fractions. Any question? Oh, that's only one of the answers. Ooh, almost missed that. So that's one of them. And the other one, move that up there. The other one is in the 4th quadrant. So this is 2 pi minus theta related, which is 2 pi minus pi by 4. So what's that?
7 pi over 4.
Very nice. Just thinking about the fractions, just 2 is like 8 minus 1 more, got 7. I mean, they are easy fractions, right? We don't like, not weird fractions. All right, I'm going to keep going, if you're okay with that. I think we got 2 more after this, yeah. Cotangent theta equals 1 over root 3. So what triangle are we in? Uh, 1, 2, root 3. And tangent is opposite over adjacent. So cotangent is adjacent over opposite. So here's my pi by 3. Oh, I made this way too small. Here's my pi by 6. Oh, yes?
On my sheet that I printed out, I don't have.
You have cotangent, we have tangent.
Change it to cotangent. Okay, so where were we? Cotangent is adjacent over opposite. It's reciprocal. So what's our related angle going to be? What do you think? Is it pi over 3 or pi by 6? Like trial and error, you could just kind of think it through. You want to take a guess, or do you know? Pi over 3 would give me 1 over root 3 as like adjacent over opposite. And if it was tan, it'd be the other, you'd have to flip it, which would still work. So good. Theta related is pi by 3. All of that was figure out theta related. We also want to think about cast. So we're talking tangent here. Taking the reciprocal of something never changes the sign. So cotangent and tangent is the same. So where are they positive there? So theta 1 is just pi over 3. It's just the same. And theta in quadrant 3 is pi plus pi by 3. So that's 3 pi by 3 plus 1 pi by 3, which is 4 pi by 3. Remember when you thought radians were easy and you're like, Mr. Belair, radians aren't hard. You said they were hard. They're not hard. It's a little bit harder, right? Because you just don't see it as much. Like you know what a 30-degree angle looks like. You know what a 60-degree angle looks like. You're familiar with it. So your brain doesn't have to think about that. It's less work for your brain to do because it's got that. And now you're like, I'm not really translating these into angles. You're not really thinking about them as angles, but they're sizes of angles. This one's fast. And then the last one is a little bit different. Okay, good. Cosine theta is -1. How did we do this question last time? We've actually seen this before in the grade 11 review. How do we do a question like this? You can do it with angles in standard position, but there's an easier way. Yeah, just think about the graph. So you got to know your graphs. Where is the cosine graph? Where is the y value equal to -1? Even if it's in degrees, because you're still fine to be translating. Somebody else. I know. I bet a lot of you in here know the answer and you're just not putting your hand up. At 180 or pi. Very nice. Okay, so that means theta equals pi. And that's it. There's not a second one. We've seen, this says up here, right, from 0 to 2 pi. So 1 cycle. So we're done.
So that's not for like the graph we draw the intervals being like pi over 2 and pi 3 over 2.
Yep.
3 pi over 2.
Yeah, very good. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, right? You can think about it that way. Absolutely. Yep. Good. And we're going to do some graphing. We're going to talk a lot about that when we start graphing. Oh, this is the one that fools everybody. Oh, I don't know how to do these questions. This is actually the easier kind. But again, it's interesting when people don't know how to do this one because it shows and it's not your fault because there's a lot to know, but it demonstrates there's like a lack of understanding. There's some disconnect or some gap in our overall big picture understanding of all this trig stuff. But it's because there's so much. That's why. It's not like you're not trying or something. I mean, in some cases it might be, but it's not for everybody, right? So that's not always what it is. Okay, so in this case, it's like the ones above, but these ones were special triangle answers, right? They're exact answers, so we could use special triangles. This one you can't, so we use our calculator, that's all. And this got cut off, but it's supposed to say round to, I can't remember, let's say 1 decimal when necessary. So people always ask, how do I know when to round and when not to? You're going to have to know. If it's a question that you can answer exact value, then you should be doing that. Sometimes the instructions will say, but I might give you questions where it doesn't. And you need to know, like you need to be good enough to recognize, oh, this is one I can do an exact value for, and this is one I can't. That's another sort of slightly higher level of understanding. Okay, so cosecant is like sine. How do we do this one? It's a little bit tricky too because of the reciprocal. You've probably never done something quite like this. So sine theta, if we take the reciprocal of both sides, oh, I'll do this in 2 steps. You wouldn't have to, but I'll do it in 2 steps. This is like 1 over sine theta, right? You all know that is equal to negative 2.4567. So what can I do? I can flip both sides. And that preserves the equality, right? So I get sine theta, because our calculator, again, doesn't have cosecant, so we have to do this, equals negative 1 over 2.4567. So our goal in these cases is always to find theta related. So I'm going to go shift sine 1 divided by 2.4567. Dropping the negative, right? No negatives going to the calculator. And I'm going to keep 2 decimal places for now because we need 1 later. So 0.42. Whoop. So let's see, 0.42, we're good. And sine is negative in the bottom 2 quadrants. So theta 3 is pi plus 0.42, and theta 4 is 2 pi minus 0.42. That's just, we get so used to doing it with the angles in terms of pi that are in the special triangles that it feels weird to do it with a decimal. And a lot of people don't understand what 0.42 is. What is that? Yeah, it's in radians, right? It's just a measurement. Okay, so let's see. Pi plus 0.42 is 3 point, so I'm rounding again because it said 1 decimal place, so 3.6. And 2 pi minus 0.42 is 5.9. I know there's a lot there, but we're going to take some time and go over it. So if you're not awesome at it on Monday, we're going to do a whole nother day. And I might do 1 or 2 examples, but for the most part, it'll be a work period. Okay, we've only got about 10 minutes now where you can practice a little bit. There's the questions that I want you to do today. And then on Monday, we're basically going to do the rest